want to start out this week by addressing a blog post from OpenAI that is making some waves across the AI space regarding an early warning system for LLM-aided biological threat creation. So the title of the blog post is Building This Early Warning System. And I read the blog post through to the end, and it's an interesting study that was done, but I believe the title of this is a little bit misleading. What the OpenAI research team did is they hired 50 human subject matter experts they had 25 students, and then they had 25 professionals in the field, and they gave them access to a research only version of GPT-4. They call it GPT-4B here, which is a version of GPT-4 that is more likely to respond in a helpful way to the types of questions involved in generating a biological threat. This is, of course, research locked. They were very careful to be sure that these weights didn't get out. This is the type of model that's very dangerous. So the goal was to provide researchers and to provide students and these are biology, like PhD students, to do a controlled test and give some people just access to the internet and access to internet boards, internet forums, internet resources, whatever. And then give another control group access to the internet and to GPT-4. And they wanted to see if giving them access to GPT-4B would make them more likely to be able to create a complete protocol. And they define a protocol in like multiple steps, which are ideation, acquisition, magnification, formulation, and release of a biological threat. And they wanted to find out if giving access to GPT-4B would significantly increase their probability of being able to create this sort of plan versus just being able to use the internet. So I think the objective here is very interesting, right? And their goal is to develop a tripwire of sorts for knowing whether or not a model is dangerous enough to be considered to check the boxes on their model evaluation system they're working on that has all these different categories of danger and risk that is ultimately a way to determine whether or not the model is too dangerous. However, the objective of the study was to come up with this tripwire, and they did not come up with a tripwire. They did not have statistically significant results. There are a few reasons here. They had a fairly small test set because these are very expensive people to hire. The experts are very expensive. These are researchers. These are very qualified figures in virology and in biology. They only had 50 experts, and they did not get any kind of statistically significant results regarding whether or not giving them usage GPT-4 would make them more likely to create this dangerous protocol. The learnings that they have here are that biorisk information is actually pretty accessible even without AI, that gold standard human subject evaluations are very expensive, which is not surprising. And the last learning is that we need more research around how to set thresholds for biorisk. There is no building a tripwire. There is no building a system to detect biological threats. I think it sounds very cool when you call it that, but this is just one step towards doing this. A very early piece of discovery research. Very happy to see the work that was done here. I think it's excellent work. I think the way that the blog post is titled and that the story is being spun around the internet in some places does not align well with the content and of the research yet, which again, I think that inconclusive research is excellent. I think that research that says, look, we actually don't have statistically significant results is way better than research that manufactures results. So this is good work that the OpenAI team is doing, but we need to be realistic. We can't jump ahead and say that LLM-aided biological threat creation is a huge problem. Next, Meta has released Code Llama 70B, and not just 70B. There are several different sizes, of course. There's 34 billion parameter, there's 70 billion parameter. These are really suited for code completion, and the performance of their instruct-tuned model. So they basically train the model, and then they fine-tuned a version for instruction, basically responding to prompts the way that a human might expect, processing natural language prompts to generate code. And on this instruction fine-tuned version of Code Llama, it very slightly outperformed the reported GPT-4 HumanEval score. I want to add a couple caveats. The first being that the base Code Llama significantly underperformed when compared to the GPT-4. The one that's fine-tuned on Python also significantly underperformed. It was only this instruct fine-tuned one that performed at a similar. This is basically a version of the model that is fine-tuned for a HumanEval type evaluation. And it did slightly outperform GPT-4, but it's unknown whether or not that means the capabilities, like the greater capabilities of the model, are actually more than GPT-4, or if this is really just a version of the model that's been fine-tuned for this specific use case of beating GPT-4 and HumanEval, which they succeeded on. So props to them. It's not easy to do. Last piece of news is a really quick one. I think it's pretty silly, but also kind of cool because we'll see what happens. In 2023, in late 2023, Neuralink was approved by the US government to stick chips in human brains. And guess what? They've done it. That's all that we know. Elon Musk says that we're getting promising neural spikes. I would expect to see some promising neural spikes if you plant a chip in somebody's brain with a whole bunch of monitoring wires. Whatever brave soldier, brave new world has volunteered to get this thing implanted in their brain. Most respect to you. I'll be taking my time before planting one myself, but you're a pioneer. That's all for this week. Stay tuned for more AI news.